Hello. This is an example of a DC nodal analysis numerical problem of level 2. So let's get started. We're asked to write the nodal analysis equations for the circuit, then compute I naught and V naught. I naught is the current on the top left there going across the 3 ohm resistor, and V naught, where's it at? Oh, at the bottom right, it's the voltage across the 1 ohm resistor, which concerns V5 and V3. So first, let's figure out how many equations we're going to need. I don't see any control variables, so pretty easy. We have 6 total nodes here, minus the ground node. We're going to need 5 equations. Click submit. Perfect. For the first equation, let's see if there's any voltage sources. There is one towards the top, middle-ish. Say 3-volt voltage source, and it connects the ground node with V1. So that's going to be the potential from the ground node minus V1 is equal to 3. In other words, we can do V1 is equal to negative 3. And I don't see any other voltage sources, so let's start doing some KCL work. Let's go to V2 on the left-hand side. There's a current source connected to that. I like to start with those. It's 10, and it's going out of the node, so it's positive. Next, let's find the current going from V2 to the ground node on the top there, which is also the value of I naught that we'll compute in the future. But right now, it's just going to be V2 minus 0, which is just V2, over 3. And then from V2 to V4 on the bottom there across the 6 ohm resistor, using Ohm's law, that's going to be V2 minus V4 over 6 equals 0. And I like to get all the integers on one side and all the variables on the other side. So to do that, let's subtract 10 from both sides. You get negative 10 there. And that's it for that equation. Let's move on to V3, which is on the right-hand side. Just got 2 resistors there, pretty simple. Let's go from V3 to V1 over the 8 ohm resistor. Using Ohm's law, that's going to be V3 minus V1 over 8. Just add that with the current from V3 to V5 over the 1 ohm resistor. It's going to be voltage divided by resistance. Resistance is 1, so we can just ignore that fraction. So it's just going to be V3 minus V5. And that'll let all of that equals 0. Let's move on to V4. We have 3 resistors there. Let's go from V4 to V2 first and find that current across the 6 ohm resistor. So we get, using Ohm's law, voltage divided by resistance. It's V4 minus V2 over 6. Let's add that with the voltage going across the 8 ohm resistor from V4 to V1. So it's going to be V4 minus V1 over 8. And lastly, for this equation, we have V4 to V5 over the 8 ohm resistor. Let's find that current using Ohm's law. V4 minus V5 over 8. Set all that equal to 0. For the last equation, let's work with V5. We have a current source coming out of the node. So it's going to be positive. That value is 9. So stick a 9 there. And I'm just going to do equals negative 9. And come back to the start here. Subtracting 9 from both sides. We have a current going from V5 to V4 over 8. Using Ohm's law, V5 minus V4 over 8. And then adding that with the current from V5 to V3 over 1. You can ignore the fraction. V5 minus V3. And that should all be good. Perfect. Let's input a matrix to solve this. Solve all the potentials. Alright, starting with the first equation, we have V1. Its coefficient is 1. Equals negative 3. Leave everything else blank. And it equals negative 3. For the second equation, I don't see V1, but I see V2. It's mentioned a couple times. We have 1/3 plus 1/6, which is the coefficient for V2. And I believe that's just the same as 1/2. Next, we have coefficient of negative 1/6 for V4. And then all of that equals negative 10. For the third equation here, I see V1 mentioned. Its coefficient is negative 1/8. Then V2 is not mentioned, but V3 is. And that is going to be 1 plus 1/8, or 9/8. V4 is not mentioned, but V5 is, and that is negative 1. And all of that equals 0. For the fourth equation, V1 is mentioned. That coefficient is negative 1/8. V2 is also mentioned. Its coefficient is negative 1/6. For V3, it is not mentioned. Let's go to V4. It's going to be 1/6 plus, we have 2 times 1/8, so it's going to be just 1/4. And then V5 is negative 1/8. All of that equals 0. You can leave it blank. For the last equation, I don't see V1 mentioned or V2, but I do see V3. Its coefficient is negative 1. For V4, it's negative 1/8. And for V5, we have 1/8 plus 1, or 9/8. And all of that equals negative 9. Can't forget that. Let's submit the matrix. Perfect, it solved it for us. Let's submit these values. Alright, now we got to compute the sought variables symbolically in terms of all of the potentials. So let's look at I0 first, which is at the top left there. And that is the current going through the 3 ohm resistor from V2 to the reference node. So the current going through a resistor from V2 to the reference node is going to be voltage divided by resistance. And that is going to be V2 minus 0/3. Or in other words, V2/3. Next we got V0, and that is the voltage at the bottom right there across the 1 ohm resistor. And the positive terminal is on the left, which is the voltage of V5. Negative is on the right, which is V3. So we're going to get V5 minus V3. Submit those. Perfect. That was the easy part. For I0, we got V2/3. So V2's value was negative 29.78. Divided by 3. And this website's awesome because it'll calculate that for you. And for V0, we have V5 minus V3. V5 is negative 55.06. And then we're going to subtract V3, which is negative. Subtracting a negative means addition. And V3's value is 49.27. Now if we submit, should be right. Sweet, all done. Thanks for watching, and I hope this helps.